This is Precalculus Onramps review. I'm going to do the first 4 questions. Let's see. The first one is the function f of x is 3x minus 12 is an x-intercept at a0 and y-intercept. So first I'm going to factor it just to make sure that nothing cancels. I'll factor 3 out of the top. 3 times x minus 4 divided by x plus 4. So there's no holes that could affect x-intercepts or y-intercepts if there's holes there. Let's see. So it has an x-intercept at a0. How do I find the x-intercept? I set the numerator equal to 0. So 3 times x minus 4 equals 0. Divide both sides by 3. X minus 4 equals 0. X equals 4. So 4. How do I find the y-intercept? That's the b. I just turn x into 0. Substitute 0 for x. So 3 times 0 times minus 4 is 3 times minus 4 is negative 12. Whoa, that's going to be ugly. Negative 12. And on the bottom, 0 plus 4 is just 4. Negative 12 over 4 is negative 3. So b equals negative 3. So the x-intercept is 4, 0, and y-intercept is 0, negative 3. Let me graph it just to prove it. 3x minus 12 divided by x plus 4, and I have an x-intercept of 4, yep, and a y-intercept of negative 3, got it. Okay, that's question 1. Let me go to the next. Next is question 2. What does question 2 ask? Oh my goodness, it's got all this stuff. Well, again, I want to factor first because I don't want to miss any holes, and it does say there's a hole. So I'm going to divide everything on top by 2, and I get x squared plus 2x minus 3 divided by x squared plus 4x plus 3. And now I'll factor this. Negative 3, what numbers multiply negative 3 and add to 2? 3 and negative 1. So this is 2 times x plus 3 times x minus 1 divided by numbers that multiply to 3 and add to 4. Well, that's 3 and 1. So x plus 3, x plus 1. And that gives me, there's a hole at x plus 3 equals 0. X equals negative 3. So I guess I could put this negative 3. And then what is the value of the function if x equals negative 3? Well, I'll substitute negative 3 for x. I guess I'll do it right over here. Negative 3 minus 1 is negative 4 times 2 is negative 8. And then I have negative 3 plus 1 is negative 2. So that is 4. 2 times negative 4 is negative 8. Negative 3 plus 1 is negative 2 is 4. So negative 3, 4. Let me just check these as I go. I will do 2x squared plus 4x minus 6 divided by x squared plus 4x plus 3. And where's the hole? Is at 3. Negative 3. See, so negative 3 undefined, and I can see that it's at, this one doesn't show it exactly, but I can see it's at negative 3. It says undefined, and then you can see it's getting close to 4, close to 4. So it's negative 3, 4 is the hole. Okay, very good. Now I have to find the y-intercept. The y-intercept is when I make x equals 0. So 2 times 0 minus 1 is negative 2 divided by 0 plus 1 is 1, so negative 2. And let me just check it. Negative 2, certainly. The x-intercept is when I make the numerator equal 0. So 2 times x, I guess I'll do it over here. 2 times x minus 1 equals 0. Divide both sides by 2. I get x minus 1 equals 0. X equals 1. So at 1, 0. And certainly, there it is. Okay? And then I have a horizontal asymptote. The degree of the numerator and the denominator are the same. If the degree of the denominator were bigger, it would be y equals 0. Since they're the same, I just take the coefficient of the largest power. So 2 divided by 1 is 2. So y equals 2. I'll draw it in here. y equal 2. There it is. And then the vertical asymptote. The vertical asymptote is when the denominator equals 0. Well, I've got a hole there, so it's just x plus 1 equals 0. X equals negative 1. So I've got that. And let me show it. X equal negative 1. There it is. Okay, that's question 2. Now I'm going to go to question 3. I think that's everything, yes. Question 3. See what they tell us for question 3. F of x equals x minus a times x plus 1 times x plus b. Divide by x minus c, x plus d, x plus 3. Correctly models the graph. Okay, so let me see. The x-intercepts are at 4 and negative 1. So this would be, at 4 it would be opposite sign, so it's x minus 4. So x minus 4, a is 4. And then negative 1 would be x plus 1, and there it is. So this is x minus 4 times x plus 1. And then b, well, b would have to cancel, so I think it's going to be 3, because it'd be x plus 3 over x plus 3. And yes, there's a hole at negative 3. So x equals negative 3, x plus 3 equals 0. So b is 3. C, where are the vertical asymptotes? I'm at negative 2 and 1. So it's going to be x plus 2 and x minus 1. That's the opposite sign. X minus 1 equals 0. X equal 1. That's where my vertical asymptote. X plus 2 equals 0. X equal negative 2. So x c is 1. X minus c, x minus 1. And d is 2. X plus 2. And is that it? That's it. So let me just put this into Desmos just to prove it. You always want me to prove it. If you're at home doing homework, prove it. X minus 4 on the test, probably no calculator test. X plus 1, x plus 3, but when you're trying to work it at home, do your best. X minus 1 to double check and make sure you're right. X plus 2, x plus 3. And let me double check it. I should have a y-intercept at 2. Yes. X-intercept at negative 1 and 4. Yep. And then I should have horizontal asymptote at y equals 1. Yes. And I should have vertical asymptotes at negative 2 and 1. X equals negative 2. X equals 1. I just draw them in so I can see them. And sure enough, everything matches. So A is 4, B is 3, C is 1, D is 2. All right, just one more. Just one more. This is number 4. I'm just going to do 4 on this video. All right, this one has a slant asymptote, but let me check. Maybe I'm not going to have to worry about that. I can probably check it at the end. So I have x-intercepts at negative 1 and 2. So x, remember it's opposite sign, x plus 1 and x minus 2. And it looks like I have a vertical asymptote at negative 1, negative 2, negative 3. So it's going to be x plus 3. And let's check it out. X minus 2, x plus 1. The only one that has those is this one, so that has to be the answer. I'm going to verify that that slant asymptote. So I'm going to FOIL this. X squared plus x minus 2x is minus x minus 2 divided by, it's 2x plus 3. But I'll do synthetic division, divide by x plus 3, and then with a negative, because x plus 3 equals 0, x equals negative 3. I'll use that for synthetic division, and then I'll divide everything by 2 to get the slant asymptote. So the degree of the denominator, or numerator, is exactly 1 bigger. X times x is x squared. This is just x to the first. So I'll put 1 minus 2, and I'll put minus 3 here. The 1 comes down. Negative 3 times 1 is negative 3. That's negative 4. Negative 3 minus 1 is negative 4. Negative 3 minus 4 is 12. And that's 10. And so this is going to be the slant asymptote, 1 degree smaller. It was x squared, so it's going to be x minus 4. Except I have to divide everything by 2. So x over 2 x minus 4. Divide everything by 2. Is it 2x minus 2? Having a trouble with this one. Oh, is that it? No, that's not it. What do I have to do here? X plus 1 times x minus 2. I already know that's the answer. I'm just trying to get the asymptote. X plus 1, whoops, times x minus 2 over 2x plus 3. And so the slant asymptote is x minus 2? No. Okay. It's x minus 4. Bear with me here. X minus 4. Oh, it's already divided by 2, so I have to multiply by 2. 2x minus 8. Multiply by 2, because it's divided by 2. 2x minus 8, and that's x minus 4 again. Well, let's try 2x minus 8. No, that's not it. Well, I guess I'll make a supplemental video where I prove this slant asymptote, but for now, I found the answer. For some reason, proving the slant asymptote is escaping me. I'll make a follow-up video and post that one separately so I can verify the slant asymptote. I'm blocked right now. My brain is not working on this. So I got the answer for the first 4.